Now students, we have spoken about the covalent compound. Now let's understand what are the different properties of that covalent compounds, like your melting point, boiling point, etc. and etc. So let's move on. So first property, as you can see on your screen, is your physical state. Your covalent compounds, they exist as gases or liquids, but some of them also exist as a soft solids. So your covalent compounds like your methane is nothing but gas. Even your ethane is also gas. As you go higher in the number of carbons, the carbon chain increases. So basically the gases gets converted into liquid as the carbon chain increases. So your methane, ethane, all are your gases. So those are your covalent compounds. So generally covalent compounds are formed in the gaseous state. Correct. So let's move on. If we talk about melting point and boiling point, we can say that covalent compounds usually have low melting and boiling points, but some of the compounds are an exception. Obviously, this is inorganic chemistry, exceptions are bound to happen. So generally speaking, your covalent compounds are having low melting or boiling point, unlike your ionic compounds. In ionic compounds, you have force of attraction, correct? So at that point, what happens? They have higher melting and boiling point because it is difficult to separate the ionic compounds. But in the covalent compounds, there are covalent bonds. Covalent bonds are formed by the sharing of electrons. So it is rather little bit easy to break covalent bond than ionic bond. Thus, the melting point and boiling point of covalent compounds are little bit less. Okay, so we can say that covalent compounds usually have low melting and boiling points, but some compounds are an exception because of the extensive covalent bonding leading to giant network structure. So what happens? Your covalent compounds, generally your hydrocarbons, are straight chain compounds. Some of them are cyclic. So those are easy to break. So they have less boiling point or lower boiling or melting point. But what happens in some of the compounds, there is very high 3D structures. There is high 3D branching. Just like if you know the diamond, your SiC, that is carborundum. So you can see the structures over here. There is a 3D network. The bonding, the carbon-carbon bonding and the catenation that happens, basically that is in the form of 3D and they have high branching structures. So it is difficult in the diamond to break those bonds, and hence even your diamond has higher melting point. You know that your diamond is one of the strongest material on the earth, correct? So that is why your diamond has high melting point, because it has a 3D network structure. So what is the next property? Let's see. Conductivity. If we talk about conductivity of covalent compounds, we know that covalent compounds are generally bad conductors of electricity. Why? Because they do not easily get separated out into the ions. Just like your ionic compounds, they get separated into your cations and anions. But in covalent compounds, what happens? That there is no separation of charges as much as your ionic compounds. So we can say that covalent compounds are bad conductors of electricity, but some covalent compounds may conduct electricity. So what are those covalent compounds? Like you can see, you have HCOOH. What is HCOOH? HCOOH is nothing but your formic acid. So formic acid can conduct electricity. Why? It can gain a proton from another molecule and it can form HCOOH 2 plus and HCOO minus. So it forms into two ions, that is your positive and negative ion, correct? So we have discussed that your covalent compounds cannot conduct electricity, but yes, there are some exceptions, like your acetic acid can conduct electricity. So your ionic compounds can conduct electricity due to the formation of cation and anion. But in covalent compound, there are very less compounds that in that case such thing happens, correct? Now similarly, there is one more exception. Like you can see graphite on your screen. Graphite being covalent and also it is non-ionic, as we all know, can still conduct electricity because of presence of mobile electrons. As you can see on your screen in the diagram given below, you can see that this is a structure of graphite, isn't it? So this graphite, as you can see, there are these yellow electrons. So these yellow electrons can move, so they are mobile and they can conduct electricity. So yes, there are some exceptions in which your covalent and non-ionic compounds can conduct electricity. Now let's talk about isomerism. So we can say that covalent bonds are directional in nature, we know that, but ionic bonds are not directional in nature. So covalent bond, since they are in directional in nature, they can show isomerism, like your geometrical isomerism, optical isomerism, cis, trans, etc., etc. So they do show isomerism unlike your ionic compounds. Now let's talk about chemical reactivity, which is very important point. So we can say that covalent compounds give molecular reactions. So covalent compounds, yes, they give molecular reactions which involve bond dissociation and bond formation. So this is very important point to note, that your reactions in the covalent compounds are generally bond breaking and bond formation type of reactions, unlike your ionic compounds. So over here, in there is a formation of bond, there is a breaking of bond. So for that, the time required for the reaction completion is little bit high. So if we compare the time required for your ionic reaction and covalent reaction, obviously the one which involves your covalent compounds will require more time, because it has bond breaking formation, bond forming formation. Thus it takes a little bit more time than those of ionic reactions. Now let's talk about solubility. We all know that your polar compounds dissolve in your polar molecules, like for example your polar dissolves in polar. So what we call it, like dissolves like. As you can see on your screen, there is a small diagram which says like dissolves like. So your polar compounds dissolve in polar solvents and your non-polar compounds dissolve in non-polar solvents. So your polar compounds will not dissolve in your non-polar solvents. So we can say that since covalent compounds can be polar also and can be non-polar also, so they are soluble in polar solvent also and non-polar solvent also, depending on the nature of the compound. So if your compound, your covalent compound is polar in nature, so it will dissolve in your polar solvent, and if it is non-polar in nature, it will dissolve in non-polar solvent. So it depends upon the type of compound, which compounds do you have, and is it polar or non-polar.